Now come to another article, algebra of functions. First, addition of functions. Let f maps from set x to real set and g maps from x to real set be any two real functions where x is subset of R. Then we define f plus g maps from x to R by f plus g of x equal to fx plus gx. The addition of functions is possible whenever their domain are same. If function f has the domain x and the function g has the domain x, if two functions have the same domain, then addition of functions be possible. Come to the subtraction of real function from another. Let f is a function maps from set x to real set R and g is a function maps from set x to real set R. Be any two real functions where x subset of R. Then we define f minus g is a function maps from x to R by f minus g of x equal to fx minus g of x for all x in the set R. For example, let f of x equal to x to the power 6 plus 1 for all x in R. G of x equal to x cube plus 4x plus 5 and f minus g of x equal to f of x minus g of x. Here x plus 1 minus x cube minus 4x minus 5. After subtraction we got our result x to the power 6 minus x cube minus 4x minus 5 plus 1 minus 4. Here we observe that the domain of f, domain of g, they are same. So subtraction of function is possible. Here f is a real valued function, g is a real valued function and they are in polynomial form and we subtract it here. Third function, multiplication of by a scalar. Let f be a function maps from x to R, be a real valued function and alpha be a scalar. Here by scalar we mean a real number. Then the product alpha and f, alpha f. This will be a real function. So it is also a real function from x to R defined by alpha f of x equal to alpha x for all x in the set x. Come to an example. 2 into x to the power 6 plus 1. So 2 is my alpha and this f of x we have taken earlier x to the power 6 plus 1. This result will be 2 into x to the power 6 plus 2 into 1, this is 2 in this form. Come to multiplication of two real functions. The multiplication of two real functions f maps from x to R and g maps from x to R is a function. This function multiplication how look like fg. Fg is a function maps from x to R defined by fg of x equal to f of x into g of x for all x in the set x. Let f of x equal to x plus 2, g of x equal to absolute of x or modulus of x. So fg of x equal to how much? F of x into g of x. So x plus 2 into modulus of x in this form. Here domain of f is a real set, domain of g is a real set for all x in the R. So fg of x equal to also in real set. Fg of x also x plus 2 modulus of x, this value must be in real set. So fg also a real valued function. Come to quotient of two real functions. Let f and g be two real valued functions defined from the set x to real set R where x is subset of R. The quotient of f and g is a function defined by f by g of x equal to f of x by g of x provided g of x is not equal to 0 for all x in the set x. Come to an example. Let f of x equal to root over of x, g of x equal to x plus 1. So f by g of x equal to f of x by g of x equal to root over of x by x plus 1 for all x not equal to minus 1 in the real set R. This was the algebra of functions. So many functions are also there. So we go to our exponential function, logarithmic function, trigonometric function, inverse trigonometric functions and inverse function also. The learner, you should comment about my classes and do the exercise yourself. If any problem, if you face any difficulty, simply write the question, mention the book, exercise, number and the question and send to my mail account biswanathsnp@gmail.com biswanathsnp@gmail.com without any blank space. Thank you.